Hello, hi everyone. Welcome back. So today we are gonna extend our series. We have been, making sure that you are understanding the chemistry in a different manner, right? We are interconnecting the dots, and we are understanding that how well we can do this. So let me just quickly put on this mic so that you guys can hear me loud and clear. So yeah. I hope now I am very much audible, right? So welcome to today's again one more exciting session. Today we are continuing the series Chemtos Chemistry ki batti jala de. And in this particular episode we are gonna discuss about how does atoms are interacting with each other. In the episode 1 we discussed about what matters is constituting of. In the second episode, we discussed about the matter around us, right? In the third episode, we discussed about how does atom look like, right? What are the different models were proposed, and how does it actually look like? So in that again we have given out the picture. I'll quickly recap that with you also, so don't worry about it. So in today's session, this particular session is brought to you by ODA Class, and this is a live learning app wherein you guys can join in and can learn from the awesome teachers which we have. This particular ODA class, we have been awarded with the most innovative edtech awards, and we are proud to carry about that. Now let's quickly look on to what are the features we have in our ODA class, in the ODA class app, right? So in that we have totally 6 different things. Foreign, we have important features which we are covering. Let's quickly discuss each of them and then move forward. So then the first one, so we are basically here right now giving you a special booster course. In that you have a 1 week duration of course, right? And in that 1 week we are making sure that you get to experience, right, how do we teach at ODA classes. So you will be getting 3 math sessions and 3 science sessions over here, and let me quickly, and you will be also getting the most important part of our curriculum, that is a dual support from mentors as well as from the teachers. So teachers will take up your doubts throughout your live classes, will make sure that you're understanding the concept, learning the concept, and mentors will help you out throughout with your journey, that you take up whatever you have learned and you are retaining that. So you will have 24/7 support from our side, so that your child or you are not feeling alone, right? So we will be there with you. Apart from that, we do always give you homework after each and every class, and that particular homework is specially made such that it's specially tuned up that whatever we have learned from that particular chapter or in that particular lecture, we are revising that and we are keeping the important points in our mind. Coming on to the 5th thing, so we have regular test cycles also, wherein we do test that whatever the concept you have learned in the class, then again you have revised in your homework, is again getting tested at our competitive base, wherein you have more than 1 lakh of students coming on and giving that particular test. So you will be getting much more idea that how and where you are exactly putting yourself onto in that competitive world. And coming on to the last but not least, the 6th feature of the ODA app is basically the ebooks module will be given to you. So in that particular e-module, you will not have to write down anything. You can simply come down, enjoy the lecture from us, and you get all the e-material support from there, right? So it is an whole package which we are sending, which we are giving students at a very minimal price, and the price for that will be either 29, 49 or 99 INR depending upon which class are you enrolling in. So this particular session is a brief trailer that how do we take up chemistry over there. So let's quickly begin and let's understand from the recap. For those of you who is visiting this particular video for the first time, for them let me quickly introduce myself. My name is Pikai Sarkar. I have done my BTech and MTech from IIT Bombay. I have 7 years of experience, have been mentoring more than 1 lakh students and counting, and I love to teach over here, right? So that's enough about me. And if you do want to come and interact, then you can definitely come through our different courses. I am taking different courses in the ODA class. You can join in at my class. Now let's move ahead And let's quickly recap that what we have learned in the previous episode. So in the previous episode, we did discuss about combining the elements. So how are we combining the elements, right? So when we are saying combining the elements, we are basically making sure that the atoms are interacting towards itself, right? Atoms are the basic building blocks. And we'll discuss much more further in this particular lecture, and we'll try to explain, right, how does elements or atoms are combining. Coming on to the next one, that is basically we focused on majorly on history of atom, right? How and when atom were discovered, right? And what are the different models which we have for atoms, right? We will be discussing that. And apart from that, we have also discussed about three major models. One was from your Thomson model, which will do the recap in a while in the next slide. The second one was your Rutherford's model, and the third one which we discussed was your Niels Bohr model, right? So we have discussed detailedly in the previous episode, and now in this particular episode we will be picking up one of the atomic model, and we will be trying to learn that if we are following that particular model, then how are we combining the elements, right, to get into the basic of that. Okay, now let's move on to the last part, which we discussed in detail, is about the current model of atom. So currently, if you see the model of atom which you might be knowing, which you might be learning in your school, right, it is quite different from what the current model is actually we are looking at. So we'll see the animation of that also, and we will do that. We'll try to explain that also in there. Now, let's understand what are the things which we are gonna learn in this particular lecture, right? So here the first thing which we will be learning is basically the interaction of atoms, right? How does two atoms are interacting with each other? What are the different ways by which it can do that? Then we will be learning about the electron arrangement. How are we arranging the electrons, and how the electrons can be arranged? How do what are the things which we can take out from that particular electron arrangement? All of those things. And coming on to the last part, that is basically writing the configuration. Writing the configuration is one of the most important part, because if you can't write down the configuration of an atom, it would be very difficult for you to understand what type of product will be formed. So we'll be taking up the next episodes, next lectures, particularly on basis of that, right? So now let's move ahead, and this slide was already given to you in the previous lectures also, that we have discussed that atoms are the building blocks, right? Now we don't need to prove that. Why do we say that to be our building blocks, right? So when you are saying building blocks, so basically we are combining atoms, right? So just like in our building, right? So it is made up of bricks and cement. So that cement is basically binding all the bricks. So here in this particular lecture, we will be discussing about that particular cementing factor inside atoms. So how are atoms connected, right? How are atoms are joined together to form the whole matter? That's what we are going to discuss. Now let's quickly move to the three things, to the history of atom which we have done. We do need to recap, we need to keep this thing in our mind before learning it. So the first thing is what we have started our journey with Thomson model, wherein he gave a plum pudding model, right? This is the model's diagram, right, animation. So here if you see, these are your plums, right? All the reason, or you in Hindi you say that as kishmish, right? So these are all your kishmish, assuming these are your kishmish, these were nothing but your electrons. So I'll just quickly write it over here. So how do you write electrons, right? What is the sign or symbol for this? So let me quickly tell you that also. So you write with E, right, small e, and a small negative sign at the superscript at top of it. This is how you are representing electrons. And then apart from that, what did he say? All the brown part, whatever you are seeing, that, and all the yellow part, whatever you are seeing, is basically positively charged. This was given by a Thomson, right? Moving on to the second one, that is your Rutherford's model. Now, Rutherford model is also called as planetary model. Why? Because if you look at this particular model, it is very much similar to our solar system, wherein you have at the center you have your sun and there is a planet which is rotating around it. Now here it is since quite similar to that. Here what he said is basically the center thing is basically your nucleus, right, and the blue electron which is revolving it is basically your electrons. So I'll just write it down, electron. Now do you see, right, the kind of modification where it became? So here what do you observe? So here in the first case we didn't have any concept of nucleus itself, right? Here it said, the Thomson said that the positive charge is distributed among all of it. But right now in the current model we have concentrated the positive charge at the center, right? Bohr on the other hand, which was the next model of it, right, what he did, he basically here modified it even further. Here in this case of Rutherford, he didn't actually said how do you arrange the electrons, but in case of your Bohr model he did that, right? So he extended that particular idea. So here if you see the center part, again here is basically a nucleus, and here if you see the electron which is revolving around it can jump from one shell to another shell. Now if you are seeing that the electrons are jumping from the lower one, from the inner one to the upper one, then the electrons are gaining the energy, that is basically it is absorbing the energy, and in the other case if it is journeying from top to the inside one, then it is releasing out the energy. If you look onto the animation for 1 second, then you will be realizing that. Just concentrate on this particular part. Now, let's continue our discussion that what was the next current model of atom, what do we actually follow, right? So there was one model which came in, which changed everything. That was model of given by Schrödinger. So this is your Schrödinger's model. I'll just underline, this is Schrödinger's model. Now in this particular model, if you see here, he talked about that the electrons are not revolving or rotating in a fixed orbit. He said that it is impossible to determine, right, from your Heisenberg's uncertainty principle. You don't need to know about that, but there is some principle. From that principle, he said that we cannot exactly point out where the electron will lie, but we can say where it can be found most probably, right? And that changed the game quite differently. And as we progress, right, we understood that rather than having just 3 subatomic particles. So what are the 3 subatomic particles which we followed or which we assumed is basically your proton, then you have neutron, and then you had electron. So these were the 3 subatomic particles which were thought that will be present in the atom, but it was not the case. We found out there are more subatomic particle, more fundamental particle which are present in any atom, right? So it changed a little bit, and then we modified our atom to this particular model. So this is just a visualization of what actually the atom would look like. Now if you observe here, so you have, so I'll just quickly change this. So here what do you observe? First thing, here you have a nucleus, right? So nucleus, what does nucleus contain? So nucleus contain again your proton, and it contained your neutron. So we will be discussing more about protons and neutrons, the properties of that in a while, but for now let's bear with it and let's try to take it up. So here we are saying that, I'll just quickly erase this and rewrite this, plus neutron. Pardon for my language, pardon for my handwriting, right? I know that is not coming as that good, but I'll try to keep it neat and clean. Okay, no worries, let's move ahead. So you have proton and neutron which is present inside the nucleus, the white part, whatever you are seeing here. Now apart from that, there is one particular subatomic particle which is called as gluon, which is present around it. Now what is the work of gluon? So the work of gluon is to glue protons and neutrons together. So these subatomic particles are basically emitted and then again absorbed, emitted and then again absorbed. And the size of this particular particle is so much smaller compared to whatever is the size of atom, right? So if you imagine your football field, if that is your atom, then a basketball which is placed at the center of it will be basically a size of nucleus, and a small grain of sand will be the size of your gluon. So just try to imagine that in the whole football field you have to find out one particular grain of sand, how difficult that would be. That's the size comparison which we are talking about, and that's why the research is continuing in that particular direction. And as if there is any kind of update, I'll update this also, and I'll make sure that you guys are also updated about it. Now coming on to the third subatomic particle, that is basically electrons, which are rotating, revolving at a very high speed. So if you are clicking a photo, so it will appear as to be it is a continuous thing, right? It will not appear as a particle, it will appear like this. Just look at this particular animation, or the diagram of the atom for a while, and then we'll move ahead and we'll discuss more and more about this, right? Now we'll try to discuss now, if let's say we have one more atom right here, and here also you have one atom. So if you have two atoms, how would these two things interact with each other? What are the factors which will make sure that we are understanding that how this interaction will move ahead, right? So now let's start it, and let's break down the atom, and then we'll move ahead. So here what do you see? So it is commonly known as atom, right? An atom here we are saying is made up of three subatomic particles for right now, for the discussion whatever we're gonna have. So here you have protons, electrons, and you have neutrons, right? Now let's study more about this. Now let's study and understand that proton, electron, neutron, what is the difference between that? So all of these three are your subatomic particles. If you're talking about protons, so protons are basically your positively charged. Which charged? Positively charged. If you look on to the electrons, electrons is basically negatively charged. Okay? And now moving on to the neutrons. So neutron will be basically neutral, right? So you have zero charge. Right? This is the first point which you have to understand about these three. Now the next thing what you have to understand is about their mass, right? Now let's understand about the mass also. So if you're talking about the mass, then if you're converting, so in a mass of an atom, we do consider the mass of proton and we do consider the mass of neutron, but we don't consider the mass of electron, right? Compared to mass of proton and neutron, that is negligible. So here if you are writing the mass of proton, so here you can write this as 1.6, 1.6 into 10 raised to the power of minus 24 grams, right? First thing. If you look on to mass of neutron, it is approximately same. So we'll keep this as also 1. 10 raised to the power of minus 24, right? This is again is given in your grams, right? This is an approximate weight, don't worry about it. You can use this particular value, you will get the correct results only, right? Until unless you are not going ahead and you are doing the minute calculation in your quantum mechanics. So we are not concerned about that. We will assume that the mass of proton and neutrons are approximately same. Now if you talk about mass of electron, so mass of electron will be somewhere around 9.1 into 10 raised to the power of minus 31 kgs, right? So this is the mass of your electrons which you have to remember. So please note it down, and I'll give you a 5-second break so that you can note it down and then we will move ahead. Now, if you have not, then kindly pause it and just note it down that we are moving ahead, right? So, now let's start the discussion about how atoms will be interacting. Now, I have given you an image, right? So, wherein we look on to the current model of atom, and we saw that two atoms are, are closer to each other. So when you are making sure that two of the atoms are coming closer to each other, we said there is some part which is positive, some part which is negative. The positive part is obviously your nucleus, right, which contains the protons, because of which it is becoming positively charged, and you have the negative charge, that is basically because of the electrons. So if I am bringing two of the atoms closer to each other, then what do we observe? We observe that the electrons of one will be basically attracted from the nucleus of this one, the first one, and the electrons of the first one will be getting attracted towards the nucleus of the second atom. Now this interaction, right, if we study and we try to plot it into a graph, we'll get a curve like this, right? We'll discuss about the curve. Now let's first discuss about how they can interact with each other. So we say that the atoms interact with each other to gain stability, and they interact by either losing or gaining of electron or by sharing of electrons. So there are two methods by which they can interact. Either one is basically complete transfer of the electrons, and the second one is basically about the sharing of electrons. So we will learn more about this in the coming series, wherein we discuss in detail that how would these all interaction will result, and what are the different properties which it will give a rise to, right? But before that, we will be learning how to write down the configuration. Then only we will be moving forward and we will be bringing in the more and more complication. In episode number 1, I did mention about there are two types of molecules. Now, how are these molecules formed? These molecules are formed by when more than one atoms interact with each other to form a molecule, right? Now you have to understand there is no fixed bond between that. There is nothing in between that. So you assume basically you have two balls of atoms, right, or two spheres of atom which are closer to each other, and in fact these two spheres are not also hard sphere, right? It is kind of a sphere which is like assume that you have made a cloud or sphere out of your cloud, right? So if I have two clouds which are interacting, which are coming closer to each other, then you will not see that these two are clashing each other. It will form, it will intermingle with each other. So that's how you assume that the atoms are also interacting. There are two types of molecules, heterogeneous and homogeneous. So depending upon if both the atoms are same, then it will go for homogeneous, and if they are different, it will go for heterogeneous. So we'll talk about that in the later episode. But for now, let's concentrate on this particular curve and let's try to understand what is exactly happening. So before going into this, now you need to understand few of the points. Let me quickly lay it down for you. So we say that whenever we are talking about any particular body, if that particular body is moving, we do say that particular particle or that particular object or that particular atom or molecule, anything might be, will possess kinetic energy, right? So can we give an example for kinetic energy? Yes, we can definitely give it. So basically assume that once you are sitting on a vehicle, right, and you have just started it and you have accelerated it. As soon as you accelerate, you will start to move, and as you move, you will be possessing kinetic energy. As you see that I am moving, right? So this movement is also making sure, or also we can say that I am possessing some kinetic energy. Now coming on to the different one more type of energy, one more variety of energy, that is basically your potential energy. So how do we understand this term potential energy? So potential, when a particular teachers say that beta you have a potential to do great things, right? Not good things but great things. So what do you mean by that? What does that particular word potential will mean? So potential will mean that you have the energy, you have the capability to achieve or to do great things, but you are not. You are storing that. So similarly, here also, in case of your potential energy, you say the amount of energy which is stored. So stored energy is basically a potential energy. Generally, potential energy is stored inside. So that's why it is written with a negative sign. So it can have positive